Good morning, students. So we'll move on to the next topic, that is direct memory access. In short form, we are calling it as DMA. Fine. So this is also one of the important question from first half of second module. Okay. So the first half, like consisting like a few more topics are available, like direct memory access, then bus arbitration we are having, then different types of buses like synchronous bus and asynchronous bus we are having. So these are the topics which we can divide it as the first half. Okay. Then later the next topic will be, our next chapter is interface circuit. Here, the next chapter will be interface circuit. So we can easily identify that first half may be consisting of topics related to accessing IO devices, interrupt concept, direct memory access, and different types of buses exactly. So out of these topics, like 4 to 5 different topics are available. Out of that, interrupt and direct memory access, both are very important. Yeah. Okay. We can also expect one question from direct memory access or else DMA we call. Yeah. So before I would like we discuss the direct memory access, I'd like to tell you one example. See, whenever we are trying to copy or we are trying to upload any file from our pen drive to our hard disk, okay, we feel that yes, processor is getting involved totally in this transmission or data transmission exactly, right? Okay, but actually it won't happen. Okay, in the backend, someone else, the third party we are using, who is responsible for transferring a huge amount of or else a block of information, huge block of information from secondary storage devices like CD, DVD, pen drive, or else like the phone memories or anyway, okay, anyone which we are trying to upload or retrieve to or from a secondary storage device. These kind of secondary storage devices. Yeah. Okay. So regarding that, we need to have a discussion with them. Fine. We feel that processor is getting involved. Okay. For the complete operation of transferring a file from pen drive to hard disk. Example, consider I have a folder called as a movie. So inside that total 6 different movies are available, each of which having size of 1 GB. Okay, so total 6 GB of information I would like to transfer from my pen drive to my hard disk. Okay, hard disk location E drive. Okay, let it be E drive. Okay, so this is what the task we would like to achieve over here. Okay, so for that, what are the procedure involved? Okay, in the backend of the system. Okay, fine, we'll see that. Okay, so direct memory access to transfer large block of data at high speed, an alternative approach is used. Okay, what we are feeling is like yes, processor is going to be involved in the entire operation of this data transfer. Okay, but whenever yes, obviously processor will be involved. Okay, but what we are feeling like continuously it will be involved, that is wrong actually. Okay, it won't happen. Right? So whenever there is a huge amount of information to be transferred from secondary storage device to a hard disk, okay, then we need to depend on some third party exactly. Okay, alternative approach. We'll see that. What is that alternative approach? A special control unit may be provided to allow transfer of a block of data directly between an external device and the main memory. Okay, without continuous intervention of processor. So this approach is called direct memory access or DMA. Okay, so here we are saying like main memory. Okay, whether it is main memory or whether it is secondary like hard disk does not matter actually. Okay, the task is what? So we want to establish a communication between a secondary storage device or its external device we can call. Okay, external device and the internal memory devices like main memory or a hard disk. So between this some kind of a data transfer if I want to perform, if the data file size is huge, okay, then what we need to do, we need to go for an alternative approach or I'll say special control unit. Okay, we need to like prepare over here. Okay, so that without continuous intervention of processor, okay, we can complete that particular task. Okay, so we'll see this how we can implement the concept of direct memory access. Okay, so DMA transfer are performed by a control circuit that is a part of IO device interface. Okay, so in first topic of the second module, we discussed regarding accessing IO device. In that, we discussed something called as an interface circuit. right? So there we had address decoder, control circuit, then data and status register. Do you remember in the bottom we had one particular like square or a rectangle. Okay, inside the three different modules were available. Okay, so along with that three module, we are adding one more module now. Okay, that we are calling it as DMA controller. It is what a small circuit which we are using to connect the external devices to our system. Okay, so wherever, observe it carefully, this DMA controller, okay, will be available in our laptop, will be available in our desktop, okay, every system, right? Where exactly, wherever there is a possibilities of data transfer in case of a huge amount, everywhere that will be available. Yeah, see, usually in case of USB drives, yes, we are like plugging the USB sticks, right? Okay, or else sometimes we are plugging our mobile. Okay, and later, in case of this, the obviously DMA controller must be available for USB ports. Okay, and also remember one more way we are having where we can get a huge amount of information or huge block of information. See, when we are trying to download any file, like a huge amount of file, any movie or all. Okay, so there also, okay, in case of network interface also, we need to have a DMA controller because there also we have a possibility like sometimes we may download only 2 MB of information like images it may be. Okay, sometimes we may download 50 MB of video. Okay, sometimes if you are trying to download a good resolution like 1080p movies, okay, then it may vary up to 2 GB or 2.5 GB. Is it right? English movies and all. Okay, so this is also one of the places where we can expect the presence of DMA controller. Okay, we'll see that there are the different locations where DMA controller should be mounted in our system. Yeah, okay. Then later, DMA controller performs the function that would normally be carried out by processor when accessing the main memory. Okay. See, whenever the processor is trying to accept any kind of information from the main memory, what all the procedure processor is following, same thing should be followed by your DMA controller. Okay. Because of this point number 4, we are also naming this DMA controller or DMA or direct memory access as second processor. Remember, we are also calling it as the second processor. Because of what reason? Because of point number 4 example. Okay, then later, point number 5, DMA must keep track of the number of word transferred. This is very, very important, students. So the DMA circuit, whatever we are having, so it should have a ability to track how many number of words that's transferred from the external device to the internal device. This is very, very important. Why? We'll discuss now. Okay. So here, next point, processor executes the program which directs the DMA about starting address of data block, later the number of words in data block, then direction of data transfer. See, whenever processor comes to know, like there is a huge amount of information to be transferred between external device and the internal device. Remember, students, processor will execute a small piece of program. Observe it carefully. It will execute a small piece of program. In the return of that, few information will be transferred to the DMA controller. What are those information? First thing, okay, about the starting address of data block. Example is 6 GB of a file we are having, right? One folder consisting of 6 different movies, each of which having size of 1 GB, right? So those 6 GB of file I would like to transfer now after selecting that or complete folder I would like to. So the beginning address of that particular 6 GB file, where exactly inside that pen drive, where exactly inside that external hard disk, or where exactly inside the DVD. Okay, so that will be identified by the processor. Obviously, okay, whenever we are copy paste, okay, we are going to copy that movie folder. Okay, we will come to E drive somewhere. Okay, and we will start pasting it, right? So in between this, there will be an exchange of some information between the processor and the external device. Okay, now processor will be having entire information regarding the starting address of the data block. First thing, okay, where it is starting, that information should be there. Okay, then later the number of words in data block. Okay, second information will be what? Out of that 6 GB, okay, a file, how many number of words are available inside that particular data block. It should be calculated, okay, and it should be informed to the direct memory access controller exactly. Two parameters we are seeing right now. One is what starting address of the information, how many words are available in that particular data block regarding that we are having. Later, third parameter will be direction of data transfer, destination. According to my example, destination is what? E drive exactly, right? Where exactly it should be uploaded. Okay, so these three parameters should be transferred for the control circuit as a return of what? Execution of a small piece of program by your processor. Okay, now what is the job of DMA now? So after receiving these three parameters by the processor, so DMA will start transferring the data beginning at that particular line, okay, particular line starting address, okay, and it will be continuously pasting or it will be continuously transferring that file to a direction of data transfer location, like E drive exactly, because it is also mentioned. Now, why it should count for the data word or why processor should intimate the controller that these many number of words are available. Remember, after completion of data transfer, complete information, okay, like consider like 10,000 different words are available in that one particular 6 GB file, 10,000 words, okay. So after transferring each and every word, processor, sorry, your DMA will be keep on tracking. Okay, in previous slide, we have one property inside the DMA that it will be continuously tracking how many number of words it has transferred. Okay, so now when that exceed like 10,000 was the word available inside the block. So each after transferring each and every word, your DMA will be counting the number of words over there. So after completion of 10,000, what should be the next? Okay, see, when the DMA finds the end of the data block, it will raise an interrupt request towards the processor that I'm done. Okay, so now after receiving this interrupt request, processor, if it is having pending request of any other data block to be transferred, that will be assigned to the DMA. Otherwise, it will just suspend the job of DMA and processor will keep on concentrating on any other. And later, after few duration, if any data transfer is expected, then again processor will execute that small piece of code. By resultant of that, three parameter will be transferred to the DMA. So DMA will transfer continuously from source to the destination. Okay, because of that fourth point has been written over here. So the second point, when the entire block has been transferred, the controller informs the processor by raising an interrupt signal. Okay, so this is what like the concept of direct memory access. The name only indicates direct memory access. Okay, where that memory is available, just access it directly. That's it. Okay, so here in this figure, you can observe processor is connected to system bus, main memory is connected to system bus, printer is also connected and keyboard is also connected. But just observe it carefully. DMA controller or disk controller we are calling it as. Okay, so you can name it as DMA controller also because we are connecting the disk over here because of the disk controller we are using. Okay, just you can just simply write DMA controller. Okay, so now in case of disk, observe it carefully. In case of disk, there is a possibility of bulk of data transfer over there, right? There we are expecting the DMA controller. Yes, we are using the DMA controller to connect our disk to the system bus effectively, right? Same thing for the network interface because we are using like torrents we are using, then using Telegram we are using, like we are starting, we can start the download of the file, is it right? Okay. Then from YouTube also, we may use some third-party software, okay, which will allow us to upload some URL, okay, and later we can download the YouTube files over there, is it right? Okay. So in case of network interface and wherever in case of our system, okay, wherever the possibilities of bulk of information transfer is expected, there we can implement the concept of DMA. Yeah, I hope you don't have doubt regarding the DMA. It's very simple. Processor will give three parameters based on which the DMA will transfer the bulk of information from external device to internal device. That's it. Yeah. Okay. So now the next topic, very important, bus arbitration. Okay. So now you may ask, like, what is the meaning of this arbitration? Okay, arbitration means like the owner kind, fine, like bus owner we are calling this, fine. Like in the given time, who is successfully using that particular bus cable for the data transfer, we are calling them as a bus master. Okay, this particular the mastership, okay, assigned to particular device will be there, right? That process we are calling it as bus arbitration. So in this bus arbitration, we are deciding that like who should use the bus cable. That's it. Okay. Remember, we are having one drawback. We already discussed from the module number 1 regarding the bus cable. What is that? Only two devices can be activated together. Okay, one will be sender, one will be receiver. That's it. Okay, if anyone else want to send in the meantime, okay, then what he need to do, he need to wait. Otherwise, he need to upload the content what he want to exchange inside the buffer registers, like data in register, data out register. Okay, many more registers are available, right? Okay, so here also we are involving the same problem. Okay, bus arbitration means like many devices are connected. Out of that, only two devices can successfully utilize that particular device, a particular, sorry, not device, particular bus cable. So we need to decide like who should use the bus cable right now. Okay, that process we are calling it as what? Bus arbitration. Decision we need to take who should use the bus cable, or else who should be made as a bus master. Bus master means we'll see this bus. What is bus master? Okay, we go through the first one. The device that is allowed to initiate data transfer on the bus at any given time is called bus master. Okay, the one who is successfully transferring the information using the bus cable. Okay, so in the given time, okay, that person or that device we are calling it as bus master. Yeah, fine. Okay. The process by which the next device to become the bus master is selected and bus mastership is selected and bus mastership is transferred to it is called as bus arbitration. Okay, what we need to do, like presently someone will be using the bus cable, right? So the next who will be using that we need to find, and that mastership should be transferred to that particular device exactly. That process we are calling it as what? Bus arbitration. Very, very important topic. Remember students, there are two approaches available. One we are calling it as centralized bus arbitration. Second one, distributed bus arbitration. Yeah. So now for the centralized bus arbitration and distributed arbitration, I would like to take an example of colleges. Okay. So now in case of centralized arbitration, I would like to take an example of our nearby RN Shetty Diploma College. I think you all are familiar, which is located in Murdeshwar, right? Okay. There, why I am naming it as centralized bus arbitration example for that RN Shetty College? Because see, RN Shetty College is like one man show. Like only one owner will be there. So this decision will be the final decision. Okay, whatever in case of recruitment, in case of selecting the fees, okay, in case of seats allotment and all, whatever his decision will be there, that will be final because that is his own college exactly. Okay, RN Shetty's own college it will be, right? But now when we are comparing the RN Shetty College with our Anjuman College, okay, so now observe it, Anjuman is in educational trust it is, right? So here, sorry, okay, so here, like we are having a trust base. So if we want to take any decision, okay, there will be a board, fine. There are some board members. Okay, we need to take opinion from each and everyone. Later, we need to go for, we need to come for a common opinion, and that will be finalized exactly. But they, like in case of, okay, in case of like single owner management and the in case of like trust-based management. Okay, I'm comparing these two. Okay, don't like consider like RN Shetty or Anjuman. Okay, let it be like one man show like colleges are available and trust-based colleges are available. Fine. So now centralized means one person will decide. Okay, who will be the next bus master? Okay, so anything like if you if processor want to be a bus master, so that will be decided by processor itself. So if memory should be the bus master, that will be decided by the processor itself. Input or output devices, if they want to be bus master, then that will be decided by your processor itself. Remember, okay, processor we are calling it as one man. Okay, the owner. Fine, that we are calling it as centralized. But here, in case of distributed, we are not involving the processor. Remember, okay, or we are not involving the processor to make a decision that will be the right sentence I can use. Okay, we are not involving the processor to decide who will be the next bus master. So what here it will be, all will take part in this arbitration election. Okay, and based on some parameter, they will be selecting one. Here, I hope you got what is the difference between centralized and distributed exam. Fine. Okay. So now we'll go for centralized arbitration. So the same kind of daisy chain variety we are using over here. So you got the processor, you got the DMA controller 1, DMA controller 2, means many devices we are connecting. That's it. Okay, DMA controller, don't see that we are only concentrating about the external device or disk and network devices. Just an example. Okay, so here we are using DMA controller. You can use a keyboard, you can use a monitor or input and output unit, memory also you can use, anything you can use, no problem. Yeah, but we are at the DMA concept, so we are using DMA controller as a device role. That's it. Okay, fine. So DMA controller 1 we have, DMA controller 2 we have. So each and every device must be connected to bus cable. Is it right? Okay. But there is some slight change in the gesture. Okay. So in case of discussing simultaneous interrupt request, we used to have only one interrupt request line, but here we are having two different lines available. And you can also observe we got some arrow marks available. Here we got some arrow marks available. See, this is unidirectional, this is bidirectional. See, in case of DG1, DG2, that is also unidirectional, something. Okay. Let me explain this figure. So this is what the centralized arbitration. Your processor will decide like who will be the next bus master. Okay. So these are the devices who are expecting to become bus master over here. Who is bus master? Who will be successfully using the bus cable for the data transfer. That will be called as bus master. Remember. So here we got total 3 different lines. Okay. See here. BR we have that we are calling it as bus request line. Bus request line. Okay. So BBSY we are having bus busy line. Bus busy line. Okay. I tell you why it will be activated. What is the use of these two lines? Okay. Then BG1, BG2 we are having bus grant 1, bus grant 2. BG stands for bus grant. Remember grant. Okay. Fine. So now feel that the many devices are connected. Like here we got only 2 devices. With that total 10 different devices are there. All are expecting to become the bus master. Then what they need to do is they need to raise an bus master request through this particular bus request line. So each and devices are connected. So everyone are having like these 2 connections. One is for bus busy line and one is for bus request. So whenever they want the service or whenever they are available with some information to be transferred to some destination, what they need to do, they need to raise a request. Okay, this is what the indication that they are raising the request. Okay, so that request will be uploaded for this particular bus request line. Okay, so you will be also uploading, you will be also uploading. Okay, now 2 devices want to become a bus master, so that request will be transferred to the processor. Observe it carefully. That request will be transferred to the processor. Fine. Okay, so now the processor will generate an acknowledgement for that. Okay, that acknowledgement we are calling it as what? Bus grant. Okay, means see, according to my example, both the devices are raising an interrupt bus request simultaneously. So processor will feel that yes, it is only one request, so he will just raise like bus grant signal 1 exactly. Fine. So now this grant signal will be traveling from processor to DMA controller. See, we are using a daisy chain. So if the second device, second DMA controller want to receive the bus grant signal, then it should be penetrated through DMA controller 1. Okay. So now DMA controller 1 and DMA controller 2 both are expecting to become the bus master exactly. So what this DMA controller will do, he will just block the grant signal here itself, and what he will do, he will just activate the bus busy line. Okay, see, when this bus grant signal will be generated by the processor, remember, when the bus line is free for communication, remember this, when the bus line is free for communication, then only the processor will grant the bus grant signal. Okay, then directly what DMA controller who is expecting to be a bus master, what he will do is, he will just activate this bus busy line. Okay, so now observe each and every devices are connected to this bus busy line. So when they find, see bidirectional we are having, when they find this line become activated, they will just remove their bus mastership request. Okay, now always they will be keep on waiting for this line to get free. Okay, like bus busy line, if it get deactivated, then suddenly those who are expecting to be a bus master, they will raise a request using the bus request line. Then same principle will be involved. Okay, so request will be transferred to the processor. So he will generate bus grant 2 now because second time it is. So bus grant 2 now. So that bus grant 2 will be coming for DMA controller 1, but he is already done with his job. So he don't have any request pending. So he will let that bus grant signal 2 to pass through the DMA controller 1. Then easily it will come for DMA controller 2. So he is expecting the service. So he will block over here. Okay, and he will activate bus busy line. Okay, see this bus busy line for what purpose we are using, so that it will be an indication to the rest of the devices that currently some device is utilizing the bus cable. Okay, and also it means that don't raise an bus request, bus mastership request right now, because bus busy line, if it is active, someone is using, if it becomes free, then only you are allowed to request it. Yeah. So now you may ask like how processor is deciding like who will be the bus master. The DMA controller, which is very close to the processor, he'll be having the more utilization, right? But remember, bus grant signal, if we are generating, then only DMA controller can utilize the bus cable. Who is generating that bus grant signal? Processor exactly. If you are not generating the bus grant 1 and 2, then devices cannot utilize the resources of the bus cable. Yeah. So now the processor is the superior one because on generating the grant signal only we can go for utilizing the bus cable. Because of that, we are calling it as centralized arbitration. Very, very simple. Don't feel confused. Okay. So if this line is active, then devices will not rise an bus mastership request. When it becomes deactivated, means when it becomes free, okay, bus busy line, if it is active means someone is using. If it is deactive means what? Nobody is using the bus cable over. Then what we need to do? The devices, those who are expecting to transfer the information, what they will do? They will just rise an signal over here. Okay, that signal will be transferred to the processor using bus request line. Okay, bus request. They want to become bus master, so that will be transferred to the processor. So processor will generate grant signal. So after receiving the grant signal, if there is a pending request in this first device, what we will do? We will just activate this bus busy line. Okay. Then those who are connected to this busy line, so they will just deactivate their request and they will wait for the bus busy line to get free over. Okay. When it becomes free, again they will raise an interrupt request. Again processor will generate a grant signal. Then again same thing. Activate the busy line, utilize the resource, later deactivate it. Clear? So this is what centralized arbitration is. Clear? Okay. So now we go for the last topic of today's class, that is distributed arbitration. Okay. So here we got some setup. So we are not involving the processor. Fine. In case of distributed arbitration, just observe it carefully. Observe the explanation. So here we got around 5 different arbitration lines available. We are not involving the processor. Remember, we are not involving the processor for deciding like who will be the bus master. So here we got some 5 different arbitration lines. Okay. So now you can observe there are 5 different lines over 1, 2, 3, 4, 5 over here. Okay. So the first line we are calling it as start arbitration. Second line we are calling it as arbitration 0, 1, 2, and 3. Okay, so you may ask like what are the use of these particular 4 lines? Remember, the devices, whatever we are having, everyone will be connected to these particular lines. Okay, so this is what an interface circuit for device A exactly, for device A. So one more example I would like to take for comparison sake. Here we are having for device B also. Okay, so here we are having for, here we are having for device B. Okay, how we are having for A, same thing we got for B exactly. Okay, so now, so whenever the device want to become a bus master, then what they need to do, they need to activate this particular arbitration line. Okay, so if this particular line get activated, okay, then the next procedure will be the devices, those who want to take participation in this arbitration process, they want to upload their unique identification ID, okay, or unique identification address, okay, for these particular lines. Clear? See, one, two, three, four lines we are having. First, what we need to do, if device want to participate in arbitration, then it should activate this particular line. Okay, fine. So that is what the indication for the other devices also, because all are connected to these five lines. Exactly. Clear? Okay. So that is indication for the another device also. If that another device is also expecting, like B, okay, if it is also expecting to become a bus master, okay, then he will also activate this particular line. Now, there will be a competition between device A and device B exactly. How it will be? What we need to do, we need to upload the appropriate address of these devices to these particular lines. Four lines. This is for what? Invitation. Okay, this is for inviting the devices, those who want to take part in arbitration. Clear? So I will take only two devices example. Three devices, it will be much complex. Okay, you don't understand the exact logic over here. Okay, so I will take just two example, two device example exactly. Okay, so now device A, if it is like 5, the address of device A will be 5. And in case of B, if it is like device is having address called as 6. So the binary representation of 5 will be what? 0, 1, 0, 1 exactly, right? 0, 1, 0, 1. See here, the device A address, we are taking it as 0, 1, 0, 1, which is equal to 5. See, 1 plus 2 plus 4 plus 8. Like that we need to calculate. So 1 plus 0 plus 4 plus 0 exactly. 4 plus 1, 5 exactly. Okay, so A is having address called as 5, that is 0, 1, 0, 1, and B is having address called as 6 exactly. What is the binary representation of 6? So 0, 1, 1, 0 exactly. Okay, so this address will be uploaded to B0 to B3 exactly. Okay, here the last one will be uploaded to 0, second will be uploaded to 1, third will be uploaded to 2, and last will be uploaded to 3 exactly. Like that, 0 will be uploaded to first line, 1 will be uploaded to second line, later 1 will be uploaded to second line to third line, and last 0 will be uploaded to fourth line. Yeah. So now between these two device address, we need to perform an OR operation. Remember. So why we need to upload this address over here? Okay. After uploading both the address, okay, what is that? 0, 1, 0, 1 exactly. Right? So I'm able to write properly over here. 0, 1, 0, 1. So later second will be what? 0, 1, 1, 0 exactly. Right? Okay. So these are the two different values we are using. So what we need to do, we need to perform an OR operation. If you perform OR operation, what we are generating here is, between 0, 1, 0, 1 and 0, 1, 1, 0. So we are generating 0, 1, 1, 1. See, 0 plus 0, 0 or 0, 0 we are writing, 1 or 1, 1 we are writing, 0 or 1, 1 we are writing, 1 or 1, again 1 we are writing. Fine. In case of OR operation, whenever we are having 0 and 0, then only we will get the output of 0. When we are having 1, 0, 0, 1, 1, 1, then we will be getting 1 x. Okay, because of that OR operation, 0, 1, 1, 1 we found. Okay, so now this is what the reference value. Fine, this is what the reference value. So now we need to compare both the device address, with this reference value. Fine. So now the device address of A is what? 0, 1, 0, 1. The address of B will be 0, 1, 1, 0 exactly. From most significant bit, we need to compare. Okay, so this is what the most significant bit we need to compare. Okay, so this is what after the OR operation, what value we got over here. Okay, when device A is equal to 5 and device B is equal to 6 exactly. In your textbook, they are taking example of A is equal to 5 and B is equal to 6 exactly. Because of that, we are writing. And because of the OR operation between 5 and 6, we are generating this particular result. Remember, okay? So now we will start comparing both the address with the reference value what we got from the arbitration circuit. Okay. So now we are finding for mismatch. Remember, we are finding for mismatch. Okay. So now, first most significant bit 0 you are having. Here also you are having 0. What you have over here? 0. All three are same. Okay. So if all three are same, we need to go for next. Okay. We need to go for next. All three are same. Okay, fine. Later, after that, next bit 1 we are having. Here also 1 we are having. Here also 1 we are having. Right. All three are same. But now, in case of device A, see, B1 position, B0, B1, B2, B3, if I consider, B1 position, what you have? 0 you are having. Here in B1 position, what you have? 1 you are having. Here in B1 position, what you have? 1 you are having. Okay. Means, when you are comparing the result address of A and B with reference value, okay, A has lost the game. Why? Because he is having 0 mismatched with the reference. Okay. But B is having a match with the reference. Okay. If here it was 0 instead of 1, observe it carefully. Here if it was 0 instead of 1, then B will be lost the arbitration game. Okay. A will be the winner. But now, in case of A, we are having 0. Okay. And in case of B, we are having what? 1 exactly. And what you are having in case of reference value is 1. Okay. 6 is matching with the reference value. Not completely, but partially. Okay. But A is not at all matching with reference value exactly. So A will be lost about the arbitration game. So B will be the winner. Okay. So now the bus master will be who? The device B exactly. Yeah. Okay. So very simple, students. So address whatever we are having, that should be uploaded for the arbitration circuit. We need to perform the OR operation. Reference value what we are getting, the result what we are getting, that should be compared with the address of A and address of B. Okay. So who is having maximum match? Okay, from the most significant bit, he will be the winner. Okay. So he will be called as bus master. Okay. Remember, most significant bit. Okay, don't consider it from least significant bit. Most significant bit means what? Here, this place will be B0, this place will be B1, this place will be B2, and it will be B3 exactly. Okay, so when you are comparing the base of B3 with base of B1, okay, so 1 you are having, 3 you are having. So this we are calling the most significant, and this will be the least significant bit. Okay, you need to start from most significant bit for A and also for the B exactly. Okay, so this is it for now, students. So this is what the explanation regarding direct, distributed arbitration, centralized arbitration under a topic of bus arbitration. And later we discussed about direct memory access also. In next video, we will be discussing about the bus cable, where we are having two varieties. One we are calling it as like synchronous bus, who is to work based on a time interval. Okay, and later asynchronous bus, where we are not following the proper time intervals. Okay, there are two varieties of bus cable. We'll go through. Okay, students, thank you. So this is it for now.